Okay, so structural workshop for this webinar series. No? So we're gonna show the integrated applications of STAAD.Pro, the RCDC, RAM connection, still Autodrafter, and RCDC FE. So at least 5 softwares we're gonna integrate, no? So directly direct integration. Okay, so this will be our sample structure, no, for the integration. So I will gonna use this model for full integration. So it's a 30 by 15 meter by 3 levels steel and concrete structure. So, and the problem statement here is how many hours you need to substantially deliver the analysis and design documents of this structure. No? So how many hours you need to spend on structural modeling and analysis, no? How many hours need for analysis and design reports preparation, design drawings, estimates, bill of materials, bill of quantities, and project schedule. No? So based on our experience, so it is reasonably to spend 136 hours of design time, for this structure, but only using structural analysis software, let's say STAAD.Pro only, STAAD.Pro, Excel, and AutoCAD. But actually, this will be composed of a team of engineers and drafters. No? So I would like to to show here that even a single engineer can do all the work, like a one-man design team. So using of course integrated software. So you're gonna see later, so kung paano. Okay. Okay, so this is how I break the 136 hours. Okay, so the 24 hours will be for modeling and analysis. Okay, and then so another 32 hours for design, review, and detailing. Okay, and then 40 hours for the drawing preparation from scratch. Okay, so it's gonna be from scratch. Then reports and calculation will spend around 24 hours, and for the estimates and BOQ, so it will be 136 hours. So below, so we are recommending the alternative and improved process, so which shown below, using integrated softwares where you can have the benefits like saving time on structural analytical modeling and reducing error. So as you can see here, so sa taas, so you're only using STAAD.Pro here, then Excel, and then here AutoCAD and Excel. So with the below recommended process, so still, so we're gonna use STAAD.Pro, so which for the modeling and analysis, so we'll have the same 24 hours. So but here pagdating sa design, review, and detailing, it will reduce to 8 hours only. So since we're gonna employ here 3 additional software. So we're gonna remove Excel here, yung inyong mga templates sa Excel, so which is you don't need to build your design templates anymore, so it's already built in with the RCDC, with the RAM connection, and the RCDC FE. So this is all full graphical. Pag Excel kasi more on numbers type, numbers type and words. So here it's full graphical. And then for the drawings, so we can reduce to only 8 hours, since all the drawings will be just extracted from the software itself. So RCDC and RCDC FE can produce high quality drawings. So which is you can just simply export it to the Excel, and then and put it on a proper title block, and then that's it. So you already have the final plan. And then for the reports and calculation, so you don't need to build your calculation sheets anymore. So since the program can generate a calculation report. Okay, and then for estimates and BOQ, so same. So we can reduce up to 4 hours. 4 hours. So since those reports ay pwede mo nang i-extract directly from the program. So taking the difference between two process, so you can save up to 60%. So 60% of your design time. So you just imagine, especially pag very tight yung schedule mo, yung design project schedule mo, so the integrated process will help you, so can help you definitely para mas submit mo ng mabilis yung mga deliverables. Okay, so paano, Okay, so we're gonna use all these softwares. Okay, so STAAD.Pro, STAAD.Pro. So we're gonna do the 3D modeling, 3D structural analysis, steel elements design, and then RAM connection will do the steel connection design. Then RCDC will gonna do the beams and column design, including the slab as well. And then RCDC FE, the new program, so we'll handle the foundation design, isolated footing, combined footing. So even mat foundation, or even if you have the piled draft, or piled mat foundation, so pwede yan, kay RCDC FE. And then RCDC and Autodrafter will take care of the drawing production, the estimates, as well as the bar bending schedule. And then, so if you do have the project schedule, written in Primavera P6 or MS Project, so you can just simply using the structural synchronizer of Bentley and with the other software called the Pro Structures. So you put the schedule, and in this direct STAAD model to Pro Structures, you can build your scheduled simulation or the 4D model. So the last part of the presentation, I'm gonna show you how. Okay, so these are the softwares we're gonna use on the integration. So 1, 2, 3, 4, 5. So 5 softwares. So STAAD.Pro is a general purpose analysis, a general purpose structural analysis software for buildings, bridges, containment structures, embedded structures like tunnels and culverts, pipe racks, steel, concrete, aluminum, and timber buildings, transmission towers, even elevated water tanks, stadiums, or any other simple or complex structures. So definitely you can use STAAD.Pro to most of any structure, even if you want to do a finite element model and analysis. So as you can see here, up to this level of analysis, so STAAD.Pro is able to perform. And then, so RCDC FE is a software for design, detailing, drawing, and documentation of planar RCC elements like flat slab, wrap or mat foundation, combined footings, even isolated footings, which are analyzed using finite element method in SAFE or STAAD analysis engine. So the RCDC FE is not only limited in importing STAAD model, but also from CSI SAFE model as well. And then, so RCDC, so it is the extension program of STAAD.Pro to design and detail concrete elements. So user can design slabs, beams, columns, walls, stairs, and footings with the aid of this program. So as you can see on the image, so hindi po ito AutoCAD drawing. So the images you're seeing on the screen are direct drawings generated by the RCDC. So the direct drawing, high quality drawings produced directly by the program. So what you need to do is just to export it to AutoCAD and put on proper title block, and then that's it. So you will have now your drawing. And then so RAM connection, so it's a tool for steel connection design. It has powerful connection check and design option with optimization. It can be used as a standalone or fully integrated with STAAD.Pro. So as you can see, RAM connection is the software mostly support connection, like most of connection database available in American design code, British standard, Canadian standard, Eurocode, British, okay, as I've said, British standard, Australian standard, as well as New Zealand standard. Okay, so these are the available design codes within the program. So available even the older design codes of AISC. And then still Autodrafter is a tool that extracts drawings and material takeoff from a structural steel model prepared in STAAD.Pro. Or it produces plans at any level and sections in any orthogonal direction. So as you can see, this is the steel Autodrafter model. So directly from STAAD.Pro yan. So pupunta ka lang kay Autodrafter mode. Then you can directly extract these high quality drawings already. No? So framing plan as well as elevation drawings. Okay, so now, so let us see the live demo. No? So we're gonna see how the software integrates together. Okay. Okay. So let me just open my STAAD.Pro model here. Okay. So this is the sample STAAD.Pro model. So we will not model this from scratch anymore. No? So since so here in the Philippines, so STAAD.Pro is the #1 structural analysis software. So most of civil engineers now and other professional knows how to model on STAAD.Pro. No? So because of lots of available tutorials in YouTube. In fact, you can also visit my YouTube channel. No? So to get some pre-trainings there, tutorials. No? So but we also offer some like paid trainings with X structures, so you can also enroll to learn deeply the program. So now let me just go here on geometry. Okay, so this is a combined concrete and steel structure. Okay, so we're not gonna do the kung paano ito na i-model, and then so let me discuss the loading here. So I use predefined wind pressure here. Then I use reference load. No, so to make this as a mass load as well as the dead load case. And then so meron tayong seismic parameters dito. Then so standard primary load cases or earthquake loading. Okay. So dead load, live load, as well as the automated wind load. Okay. And then the standard load combinations, okay, for the design of elements, okay, like beams and columns, steel beams, steel columns, concrete beams and concrete columns, load combinations for serviceability like drift, and load combination for foundation design as well. So because we're gonna design foundation later on this webinar. Okay, so so we're gonna use STAAD.Pro from the 52 hours. So we are proposing to finish this this design project. So we're gonna use STAAD.Pro for modeling, loading, as well as steel design. Of course, the drift check will be done with STAAD.Pro as well. So for steel design, so bale, we're gonna go here on post-processing. So I'll just go directly on the output. And then let me just turn off the utilization ratio. So I specifically design some of the steel elements only. So I did not design all. And as you can see, these numbers represents utilization ratio. So as long as the utilization ratio is less than 1.0. So this means that the steel section is adequate. Okay, and then if you want a, you can review the steel design here, the summary of the output of the steel design. If you double click this member or any member, double click, and then so you go here on steel design, and so you're gonna see here the ratio. Okay, so it's a pass, no? So even the slenderness ratio is reported here, and the critical load combination as well as the critical load. So in summary, you can view the steel design output here, but if you want a more detailed output of the steel design, you can go here on utilities, and then so you review it from the analysis output. Okay, then let's go here on contents, and let's say if I want to view the member 406, so you're gonna get this very detailed steel design output. Okay, so okay, which is this one, no? And of course, part of the STAAD role, no, on the integration is to do the drip check. So if I double click this, okay, if I double click this, so the program will say if it is pass or failing. No? So the input here is just the allowable drip. Okay, and then let's STAAD.Pro check if the structure is a structured drip will be more than the allowable. Of course, if it is less than the allowable, so the program will put here pass, and if it is excessive, so the program will put fail here, no? And it's up to the designer now to to change some of the member sizes, no, in order to pass the drip requirement. Okay, so that will be the STAAD role: modeling, steel design, and drip check. Okay, and then with that, so we're gonna go with the steel connection design. No? So steel connection. So we're already done with the steel elements design. No? So now for the connection design, so we're gonna go with the RAM connection. So there is a direct link of RAM connection with STAAD.Pro. So the user just need to go here on connection design link. Okay, just click close. Okay, and then you can design any types of connection here, no? So beam to beam connection, beam to column connection, bracing connection, base plates, or even this X bracing, no, with 8 members. It can be designed as well in RAM connection. Now I'm gonna only show one sample connection design here, no? So which is beam to girder connection. So as you can see, okay, this one. So beam to girder, no? So beam to girder. Okay. Then so this is the situation of the joint, and I'm gonna design the connection there. So first is you need to choose which load combination, no, you will use on your connection design, either ASD load combo or LRFD load combination. And then so you choose your design code, okay, either ASD or LRFD. So I'll be using the latest LRFD. Just click OK. Then I will now choose appropriate shear connection here, no? So since there is a member release at the end of the member, so our intention is to have a shear connection here. So there are so many types of shear connection you can use on joining beam and girder, no? So there is a double angle bolted connection. You can also a shear end plate. You can also use the most common one, which is the single plate or the fin plate, no? So which I'm gonna use on this joint. So I'm gonna go here on smart connection. So I'll click this smart connection, and then I'm gonna use a single plate here, single plate BG. Okay, single plate BG, and so you're gonna see the thumbnail of the connection here. Okay, so single plate. I'll bring this to the right side, and then I'll just click OK. and then the program says it's okay, no? So it's okay, no problem with the connection. But as an engineer, so you need to check the output of the program, no? So hindi lang natin basta siya i-accept, no? So we're gonna review, no? And that gray triangle, no? Gray triangle symbol, so that represent joint connection, no? So if we double click that, okay, so you're gonna see this connection design. So we know that there is a plate there, no? There is a weld, but we don't know what will be the thickness of the weld. So what is the thickness of the plate, as well as the diameter of the bolts. So to know these details, we can simply go here on the accept view, okay? And then, so this is already the detail, no, of the connection, okay? So, okay, but some of the distances here, dimension here, are in decimal, which we can simply edit. So let's say this 38.1, so I can change this to 40 mm. Okay, so 40. And then this one, let's say 30 mm. Then the cope length, I can make this, let's say 95 mm. And the bolt spacing or bolt gauge, I'm gonna use 75 mm. Okay, so I think it's all dimensions now are okay. Okay, so let me just save this. And as you can see, there is the connection design is interactive. No? So since the UC ratio change accordingly whenever you change something on the connection configuration. So if I make this 4 bolts, let's say here, I make it 4 bolts. So the UC ratio change into 0.11. No, so but anyway, I'll just bring this back to 3 bolts only. So that's already okay. And then, so this detail will not be wasted, no, since you can export this to the accept and use it as a as like initial drawings. Now, let your drafter, or if you can simply furnish the dimension style here. No, so but you already saved the the manual drawings, no, which we normally do. No? So you already have at least a digital form of the connection detail. So like this. No? Now the next thing is how you gonna justify this connection design. No. So the program already give the thickness of the plate, which is 6 mm, 3 bolts, 3/4, which is 3/4 diameter, no? And even the spacing of the bolts, the weld thickness, which is 3/16. So how you gonna justify this detail, no? So this program produce calculation, of course. So you just need to go here on results. Okay, so this is the result. And then, so as you can see, so it checks, no, it used, no, all the load combination, which we pick around 120, around 27 load combo, no. So even if it is 100 or 1,000 load combination, it will be checked one by one, no, by the program. And this is the summary. No, summary of the calculation, okay, which is this one. And this might be a 1 page of calculation report only, no? So, and if I'm going to review this connection design report, no, so I will not gonna accept this, no. So I prepare a much more detailed calculation, but no problem with that, since the program can produce a much detailed calculation report. So you just need to pick this or press this alpha tool here. Okay, that single page. Okay, so that single page report, so might become around maybe 6 to 10 pages of very much detailed calculation report, no, for the connection design. Okay, so what you need to do next is you either export this to Word, no, or you print directly through PDF and include it on your like a standard template calculation report. Okay, so I'm gonna close this. I'm gonna save, no, and then so let me just show you some other connection type here. So you can also design a base plate here. So this is a base plate connection. Okay, so the base plate design not only limited to check the thickness of the base plate, no, but also the much more critical the anchor, no. So the anchor is being checked as well as per the Appendix D of ACI, and yeah, so it checks, and if however the anchor the design is critical, so there is option also here if you want to include the reinforcing of the pedestal as additional reinforcement to your anchor. Okay, and then also you can design a moment end plate here. So as you can see, so very popular in Middle East countries on using this moment end plate. Also, haunch connection. So you can also use, or you can also design haunch connection. Very popular as well in the Middle East, especially in warehouses or rigid frames. Also, bracing connection, okay, chevron brace connection, and this one single plate we already shown, you know. Then even direct weld as well, no? So beam to column direct weld connection. Okay, so we're done. We're already with the steel connection design. So the next step here is how you're gonna produce the drawings, no? So it's okay. So you already finished the analysis and design, but where is the drawing, no? So which we are getting paid, no? Okay, so because doon tayo binabayaran sa submitted drawings, no? So how you gonna produce the drawings? Okay, so we're gonna go here in Steel Autodrafter. Okay, so just click the link here, Steel Autodrafter. Okay, so now here is the model. Okay, this is the Steel Autodrafter model, where so if I select this member, no, just by selecting this member, so you can produce either a framing plan or elevation drawing, no? So if I select this member, I do right click, and then let's say I want to produce a framing plan, no? Okay, so I just click that, and I will click this draw tool, and then so this is already the output. So as you can see, very high quality drawings, no, produced by the program. Okay, so you already saved time, no, on producing these drawings. So you the drawing already has grid lines, no. So even exactly this web thickness, this flange thickness, no, exactly drawn as per the STAAD section. Okay, so you already saved time on preparing the drawing as well as for the checking the members if it is like placed right, no. Okay, so because sometimes if we're giving this task to the drafter, no, so you give the scratch drawing to the drafter, and then let drafter do the drawings, and then you will gonna check after he drawn the plan, no. So dun pala makakasave ka na ng time because you don't need to do that anymore. So you just extract this drawing directly from the program. Okay, so then I will also produce elevation drawing, no. So from this member, right click, and then so I will draw section, and then click that, and so this is the elevation drawing. Okay, so meron ng elevation marks, no, concrete and steel sections, no. So drawn, no, automatically with the high quality output, of course. Okay, so So you can produce at any plane here, ano. So kung saan mo gusto mag-place ng drawing, so walang problema. Even on the other direction, let's say here. So I'm gonna select this member. I do right click. Then let's say I want to produce elevation drawing here. And then I just click this one, and then that's it. So that's already the drawing. So if you just imagine, ang laki nung masasave mong time, no? So with the Autodrafter, no? Yeah. So that's why. So we can prove that we can save as much as 60% of your design time, no? So using the integrated softwares. Okay. So now we're already okay with the STAAD.Pro. We're already okay with the RAM connection and then Autodrafter. Now, so we're gonna go with the concrete design, no? So which is we're gonna design beams and column, no? Concrete beams and concrete column, where we'll need to use the RCDC, no? So RCDC. So there's a direct link here of RCDC, no? So i-click ko lang ito, okay? Okay. Then, okay. So, unang-una kong gagawin dito is just to pick NSCP 2015. Oh, this program already supports NSCP 2015 recently, no? And we from Extractures like prepared all the necessary calculations and technical notes, no, for the NSCP design code, and we gave it to Bentley developer para mapunta yung NSCP design code within the program. Okay, so now I'm gonna just call this beam design, ano. Okay, so beam design, and then so let's say client. So I'm gonna use, let's say, X structures here, no? And then so you can put your initial here. Okay, so beam design, structures, so your name, no, and which design code so you're gonna use, and then so we're gonna design the level 4 meters, no? So we'll design the level 4 meters, and then so we'll click create new project. Set. Okay, so that's it, no? Then so the program will automatically produce this framing plan, ano? So again, you already save on drawing preparation kasi may framing plan na, no? So as you can see, no? So export mo lang ito kay AutoCAD, ano? So now, so I'm gonna set the primary load cases here. So I'm gonna set this to earthquake, no, and this one dead load, live load. Oops, this one is roof live, and then wind X, and this one is wind on the Z direction. So I'm gonna bring this to the right side and just click OK. Then so we're gonna get the load combination from STAAD.Pro. So I'll just click add from analysis here. Okay, so I'll just click no here, no, and then so I'm gonna pick load combo on 100 series only. Okay, and I'm gonna remove some other load combo. Okay, which will not be used on the design. I'll just click OK. Then I'm gonna go here on settings, and I'll go here on general and reinforcement. Okay, so we're gonna use a special moment frame as our standard frame here in the Philippines. Then so I'm gonna use a 5,000 PSI concrete here, C35, and grade 60 steel. And then we're gonna use minimum 16 rebar diameter, so maximum 25, or maybe we can use 32. Okay, we can use 32. Let me uncheck this. Then so I'll just control the maximum spacing of the stirrups into maximum 200 mm, and then 200 mm spacing. I'll just click OK. Then that's it. So we're now ready to run the design. Okay, I'll just click auto design here. Okay. And then that's it. No. So okay. So all the beams, are already designed, but we can also group them by going here, modify, and then auto group beams. So then automatically all similar beam design will be grouped by the program, and will be put on the schedule as a one, like a one piece of like beam detail. So now we already grouped the beams. So ang next lang na gagawin natin dito is to produce the schedule. So I think I need to open my AutoCAD here. Let me just open the framing plan. Okay. For me to show you kung ano yung gagawin nyo next after the RCDC. Okay. Okay, that's it. So I have a framing plan here already. It's a title block. Then, so I'm gonna produce here the text schedule. Okay, so automatic group beams, click OK, and then that's it. So you already have the framing plan, and then so you already have the beam schedule. So I'm gonna export the framing plan. Let's say it's a desktop, let's say plan, and then for this one, I'm gonna click save, and then I'm gonna call this as SCAD. Yeah. Okay. So now I'm gonna open those DXF drawings. This one, plan and schedule. Okay. And then, so I'm gonna copy this and then put it on a title block, so like this. Okay. Yeah. Then, as well as the schedule, and here, so that's it. So the kasha. Okay, we can scale naman. So we can move this little bit, like that. And then, so we paste the schedule here. Kasha na siya. Yan. So like this. So you already have your framing plan and you have the schedule. So very easy. So makaka-produce ka directly from the software. And then, so how you justify this design? So how you can justify this beam design? So you can just simply go here on reports, and then go here on design calculation. Let's say this one. And let's say, so there's so many beams here. Okay, so kasi kung ano yung lahat ng beam dun sa framing plan or level na yun will be designed by the program. So let me just choose this B30, just to show you the calculation. Okay, so beam design calculation. Okay, and also it will be shown here what design code you use on the design. So so we use NSCP 2015. So it's reported here all the chapter 4 clauses from the NSCP are being referenced here, and some other additional clauses from the ACI. And so these are the design output. Okay. Okay. So now And also this program can produce elevation drawing as well, no? So if you want to produce the elevation drawing of this beam, so just go here on reports and then you click elevation and section. So let's say this is G3, no? So but we can produce, no, all of the beam drawings. So let me just check all of this. I click OK. And then, so this is already the elevation drawing that you can also export, no, to AutoCAD. And I think we can have a better drawing somewhere here, no? So here, so since there are secondary beams here connected to this gear there, so section 1, 2, 3, 4, 5, no? Then let us review that drawings here. So as you can see, so we need 2 layers of reinforcing here, here, and here, no? So as you can see, as you notice, this is a good quality drawings already, no? So but automated by the program. Okay, so I think no more editing na kailangan mo pang gawin dito, no? So it's already a good drawing. So then you just export this, no? Then you already have the drawing. But my intention here is not only to produce the elevation drawing, but to produce the bar bending schedule, no? Bar bending schedule, no? So mas mapapadali yung iyong trabaho, no? So you just go here on BBS, then you click generate BBS here. Okay, and then with the same beam groups, no, group 3, no? So but you can produce all of these, no? But I'll be showing that beam groups only. I will click generate, and then that's it, no? So this is the elevation drawing, no, with the rebar tag marks here. So what you need to do is just to check, no, the detail of any of the rebar here from this table, no? So ayun, so the anchor lengths, no, shown here, as well as the crank, no, crank length, and even the detail of the stirrups as well, no? So drawn here. So this is already a bar bending schedule. Okay. And also what I like with this program is yung BOQ, no, and estimate. So you go here on reports, and then so you go on below quantities. Okay. Then, so let me just click this one, BOQ, and nakaset na ito sa peso, no? So even the peso currency here is already added, no? So let's say concrete is 5,000 pesos, and then let's say the steel is 50 pesos, no, per kilogram. So I will just click OK. And then, so that's it, no? So for that whole level, no, so we'll be needing 41.53 cubic meter of concrete, and then so we need around 5,800 kilogram, no, of steel. And what I like here on this BOQ is this design metrics, no? So very important, especially dun sa let's say design manager lang na alam na yung ratio bit ng reinforcement, no, compared to the concrete volume. So the program gives the weight of the steel compared to the volume of concrete, no? And please take note that this rebar to concrete ratio, no, so included dito yung mga anchor lengths, splice length, no, anchor length and splice lengths. Okay, so it's much more precise, no, than doing it manually. So mahirap gawin ito, i-estimate mo pa lahat ng rebar, no? So where the program can just simply give you this ratio, no, at instance, no? So pag na-design mo na, so hindi ka na mag-estimate ng rebar. So you already have this output. Okay. So okay, so that's it for the beam design, no? So gonna be using RCDC. So the next one is I will gonna be doing yung column design na, no? So let me just double check the final plan. Okay, so ito yung ating final plan, no? And then for the report calculation, so you just get it from the reports, no? So it's either you print it, no, export it on Word or directly print it through PDF. Okay, so now let me just close some of the unimportant drawings here, no, so hindi natin kailangan ito. Okay, yeah. So after this, I'm gonna close this, and then so lilipat na ako kay column design, no? So to column design, so we'll just go here again on RCDC. Okay. Then again, no, so NSCP 2015. So I'm gonna call this column design. Okay. So client, text structures. So engineer, no, I just put my initial. Okay. Column and wall, okay. Design code, okay. Now I'll just click create new project here. Now, okay, so lagi naman ito kay RCDC, no? So save muna natin first, and then we set this basic load cases, no? So EZ, dead load, and then live load ito, no? And this one is root live load. Ito ay WinX, WinZ, WinZ. Okay. Okay. Now just click OK. And then again, so we're gonna bring the load combination here from STAAD.Pro. So click add from analysis. Just click no. Okay. So we might accidentally remove some of the load combos, kaya pinrest ko yung no. Now we're gonna include the 100 series load combo. Select. So also this one up to 127, and removing other load combo and select. Okay. So up to 127 series, I will click OK. Then we're gonna set the design settings here. Okay, so it will be a special moment frame, and then we're gonna use a single rebar here, and I will just click OK. Then I'll go here on settings and then reinforcement settings. So we're gonna use minimum 16 rebar diameter, maximum, let us see, maybe 32 is possible, no? So but anyway, the program will automatically select from 16 diameter up to 32 diameter. Then so I will control the spacing of the stirrups, maximum 150. Okay. I think 100 would be okay. Okay. So now, so I'll just click OK here, and then I'll just go here on level data, and so we're gonna use here C35 concrete, grade 60 steel. So we're gonna use 40 mm cover here. So I just copy all this detail, paste, also paste here as well. Okay. So now all okay, and we're now ready to design all the columns. Okay. So I just go here on design and then click auto design. And then that's it. No? So the program already designed all the columns. So what we're gonna do next, since we have so many column design here, so the program can automatically group them, no? So kung ikaw ang gagawa nito, pag-group nito, especially if you have like multiple levels of column, so nakakahilo yan, ano? Very time consuming, tsaka confusing, no? So but since this is a computer program, no, kaya niyang i-determine yung mga columns na may magkakaparehong detail, no? So which we're gonna do, we're gonna use that software capability, no? So just go here and modify and click auto group columns. No? As you can see, so we have 24 different column design. So if we go here and modify and then click auto group columns, okay, and I just click OK. So pwede pala natin siyang i-group into 3 lang, ano, 3 column detail. No? So which the program already did, ano. So and also what I like here, the programs also put the rebar ratio here, no. Okay, which is this 1.4%, 1.74, and 1.11. Now, the next thing na gagawin natin dito is to produce the detailed drawing or the column schedule, no? So I just click detailed drawing, and then I'm gonna check all of this column, just click OK. And then, so this will be the column design, no? So, so most of the square columns, no? So are having similar detail, no? So kaya nag-group siya into one lang, no? So 600 by 600, and you need around 16 pieces of diameter 20, no? And these are the ties reinforcing. And then, so ito naman yung for the circular column design, no? So we can use diameter 20 here, and then so some other circular columns, so we need diameter 25. So same way with the with the beam design capabilities, no? Yung calculation report, yung estimate, no? Yung bar bending schedule. So you can also produce, no? You can also produce, no, in column element, no. So siguro I'm gonna produce even the design report as well, no. So pero mag-focus na lang ako dito sa my bill of quantities, no. So because one more important for me here is the the rebar to concrete ratio, no. Lagyan ko lang ito 5,000 pesos, let's say this one is 50 pesos, no. Then just click OK. So we need around 34 or almost 35 cubic meter of concrete, and we need around 9.49 tons of steel. And for the column design, no, so it shows here around 274 kilogram, no, per cubic meter for the column design, no. Yeah. And then, as I've said, you can produce, no? So you can simply export this to AutoCAD, as well as the this schedule, no? And then you can also produce a similar framing plan or column layout naman, no? Pag sa column, so like this, no? So so you need additional title block, no? Tapos you put the column layout as well as the column schedule, no? So very quick, no. You can finish the project, no? Okay, so ngayon the program can design as well as slab, no. So but I'm not gonna be showing that na, no, on this presentation. So what I'm gonna do next is to show the foundation design. Okay, so I'm gonna close this. Okay, so now engineer can use any of the integrated software with STAAD.Pro. Pwede mong gamitin si RCDC, no, for the putting design. Okay? Kaya lang mag-overlap kasi yung mga putting dito sa gitna, no? So on that case, so you'll be needing a matte foundation. So RCDC is not able to design matte foundation design. So since limited si RCDC for isolated putting and pile cap putting, no? So for combined putting, for isolated, combined putting as well, matte foundation, so you can use STAAD foundation, no? So but on this webinar, I will not use STAAD foundation, so I'm gonna be using other software, which is the RCDC FE, no? It's a new software from Bentley. So kasi there like some other ways to design yung footing. It's either you use a rigid method or you can use yung elastic method, no? So pag if you're using RCDC FE, so ang ating intention with the foundation design is using the elastic method. No, so on this case, I prepare a separate model, no? Separate model which already modeled yung foundation, no? So on this, and also you can use this model, okay, as to do soil structure interaction analysis as well, no? So bale, ganito na yung model. Okay, so which will be this one, steel, no? Concrete and steel structure yan. Modeled lang yung foundation, no? And so there's local thickening here as well, no? Then, anong magiging support type mo ngayon if you model the plate itself, no, as your foundation? So it will be a spring support now. So pupunta tayo dito sa may supports. Then, so the supports here will be in a form of subgrade modulus, no, which is compression only spring, no. So it will be a plate mat option, Y only, and you put the subgrade modulus here, no. So for a quick calculation, so we're multiplying the soil bearing capacity, no, by 120, and that will be our subgrade modulus value, right? And so then I apply those support, this support to these plates, you know. Okay. So then, so after this, so you just run the analysis, and for the load combination, sa foundation design kasi we need two sets of load combo, no? So service load combo for the serviceability check as well as for the actual bearing stress check, no? So we're using service load combo. And for the rebar design as well as for the punching check, we're using a factored load combo, no? So which is already set here, no? So load combination 300 and load combination 400. Okay, so actually kay STAAD.Pro pa lang, no, if we go here on post processing, apply okay, and then so I'm gonna set the to 300, no? So 300 series is our load combination 300 series, okay, is our service load combo, no? So I can use all the load combos to check the actual soil bearing stress, no? So let me turn off the, anyway, let me turn this off. Then I will just click plate stress here, and I will set this to base pressure. So click apply. Let me check if this will work. Okay, that's it now. So enhance, apply, and then click OK. Let me turn off the displacement. Then check the actual soil bearing stress here, no? So yung ginamit kong soil bearing capacity here is 200 kilopascal, no? Kaya naging 200 kasing ginamit ko dito. Then I just multiply it by 120. So I have the 24,000 kilonewton per cubic meter subgrade modulus. So ibig sabihin nito, so actual soil pressure should not be more than 200, no? So we're gonna check, let's say, so sa 300 series, okay? So we're gonna check if there are more than, okay, 200 kilopascal here, no? So but this is a pre-designed structure, so walang more than 200 kilopascal na actual bearing stress dito, no? Okay, so which is okay yung ating structure. Ngayon, so after this, we're now ready to design the plates, ano? Okay, so it will be checked for punching, and also it will be designed for the reinforcing, no, or rebar. So I'm gonna close this, and then I'm gonna open RCDC FE, no? This one is RCDC FE. Okay. Okay, So now, so this is the interface of RCDC FE. So we're gonna use 318M 2014 here. No? So project name, I'll just put here foundation design. Okay, client name, X structures. I just put my initial here, and here I will click this, and I will import this model, yung ginamit natin kanina, no? Tapos I will click start. Okay, let me just click this one, cancel. Just click yes. So nag-start na siyang mag-import ngayon ng model, no? So will take time. Okay, so depende sa size ng yung model, no? So reminders, ano? So for FB and Zoom, may link posted on live, doon mag-register, no, para maka-join sa raffle. Okay. Yep. So thanks admin for reminding. So anyway, so let me just discuss, no. So posted live, doon mag-register. Okay, so yung mga hindi nakakapasok, pwedeng mag-register doon sa FB live link, ano. So you put your name there, then we're gonna pick, no, mga yung lucky viewers po, no, or attendees nung ating webinar. So let us see if we can extend up to 70, but 50 is okay, no. So pag marami talagang attendees, no, so we're gonna extend, no, additional prices po, no. Okay, that's it, no. You don't need to make screenshot kung nag-register na, no. So since we have the link na, no, once nag-register kayo, okay na yun, no. So we have your information, tapos magra-raffle draw lang kami internally, no, sa since it will take time. And then so we're gonna post it on our Facebook page po, no. And also we will send you email kasi we have your information, eh. We send email and then we text you that you win sets of merchandise po, no. Okay, so this is already the exported model, no. Actually, ang ganda nung graphics niya, no. Okay, so isolated footings as well as the matte foundation. Okay, so gagawin ko lang dito is i-set ko yung load cases, no. On this case, we need the 4,000 load combo, which is the factored load combination. Since factored na kasi ito, set ko lang siya as, kasi combination na siya, no? So I'm gonna set this all to dead, and I use repeat load anyway, no? So I'll just bring this to the right side, so click OK, and I will just generate here as regular, and I'm gonna, since ultimate na to, factored na, so I'll just replace this into 1.0. Okay, so 1. Okay. And then, so I'll just click OK. So then, so we need to set the reinforcement. No? Just click this one. Then, i-right-click ko lang ito. No? So minimum steel rebar, we're gonna use diameter 12, maximum 25. No? Okay. Then, just click OK. Then, we set the design parameters. Okay, so we're gonna use C35 concrete, so grade 60 steel. Then, so 1 meter strip. Now I will just click OK. Is there a new registration for this Zoom attendance? Actually, if you registered already, I think okay na yun, ano? So we already have your information. Then with that, so we're gonna pick na lang po doon. Even yung certificate will be based on the registration po. Hindi na kailangan ng screenshot. Okay, so we know kasi also admin, ano, on the on paki-screenshot po yung yung ating attendees list. Okay, so admin, may admin po, no. So there are 3 admins joining here, no, on this session. Okay, Okay, paki-screenshot po yung ating attendees, no? So since you use naman all your names, no? Okay. Yan. So then, so ima-match lang naman namin ito eh, no? Ima-match namin yan with the registration. So tapos yun po, bali will ano na, will yun po, we're gonna issue yung webinar certificate. Okay, done na ba to? Okay. Mag-send ng screenshot. Okay, so si admin pala mag-send daw ng screenshot. Okay, it's okay. FB Live baka di po napansin. Okay, so okay, let me just clarify. So as per the admin instruction, no, doon sa nanonood doon sa FB Live, no, so mag-send ng screenshot ng shared post. Okay, so because they're sharing our FB Live. Okay. Anyway, so we're gonna continue now. No, okay na yung ating RCDC FE settings, no? Then after this, we're now ready to design, no? The foundation. Okay, just go here on design and then click design. Okay, that's it, no? So kanina iba yung 3D model niya, no? So what you can see is the 3D rebar design already, no? Color coded. No, so you can see here. So when you click this rebar, so automatically nagse-select siya doon sa model. Okay? So itong diameter 12 at 150, so standard mesh siya nung rebar design. I mean nung rebar design, ano? And then so we need some additional rebar, no? So which is this one, diameter 60 at 150 and diameter 20 at 150. So although it's good to see the rebar on 3D, no? So pero paano siya in a 2D form, no? Sa 2D form, which is yun yung ginagamit natin for as construction drawing, ano? So we can go here on report and then so you just click this one, drawings. Okay? So i-produce na natin bottom reinforcement, also the top reinforcement, and the text schedule as well, no? So then if we click OK, and then that's it, no? Okay, so this is the concrete plan, no, of the foundation. So with the localized thickening, no, nung foundation. Then this is the bottom reinforcement plan, no, bottom reinforcement plan. So these are reinforcing B, no, reinforcing B. So generic yan si reinforcing B as diameter 16 at 150 mesh, no? So X and Y direction. And then so mostly B, no? Same naman, ano? B sa ating mga footing. And then for the mat foundation, so A and B here, no? So A is diameter 12 at 150 and on other direction is 16 at 150, no? And then so si reinforcing C, ito ay mga additional ito, no? So due to high stress dun sa footing, so let's say here, no, kasi nasa gitna siya, no? So we will be needing additional rebar here, which is diameter 20 at 150. So dito combination siya eh. So 20 tsaka diameter 16, no, with the same spacing. Okay, so this is for the bottom rebar, and then this is for the top rebar. Okay, so which is this one. Okay. Ayun, and then so if you want to produce the calculation of the footing design, so we can go here on report, then calculation. Okay. And then so dalawa, no, for the rebar, this for the element design, no, so including the rebar design and also for the punching check as well, no. So let's say let us see S1, no? S1, click OK. Anyway, so where is S1 here, no? So S1, if we go here on view and we click slab, let's say. So S1 is this one, I think. Okay, this is S1. Ito yung mga foundation level natin, ano? S1, S2, so S9. And if you want to show the column labels, so yeah, C1, C2, C3, and so on. No? So, but we're after the foundation label, ano? And then so this is the rebar design for that foundation. And then for the punching check report and then calculation. So also, let's say, okay, so sa C3, ano. So let me just cancel this. So si S1 kasi, view, let's say, so bali C3 siya, no, for the punching check. Go here on define, and then, report, no, and then calculation, so C3, and then, so this is the punching check, no, for that specific slab. Okay, and then of course the BOQ, no, quick BOQ. Okay, so the program is also producing. This is the bill of quantities, no, so per slab. Then so then after this, so we're already done with the foundation design, no. So we check the actual soil bearing stress, no, on STAAD, but for the element design, so we use RCDC FE, no. And for the last part of this presentation, no, last part is will be the 4D model, no. The 4D model. So if you have the check this one. Okay, so if you have the MS project schedule, and then you put it together, no, the STAAD model and MS project or Primavera schedule to Pro structures. Okay, so which is this one, no. So not as the exact model, no. I just use this model, and then so you can produce this scheduled simulation, no. So like this one. So if and you can also play, no, automatically. Let's say, let me play. And you can also visualize here. So what will be like your accomplishment, no, based on your plan, no. So let's say here October 2019, ano. So at least alam mo na kung ano na dapat yung na-install, no. Then you can compare the 4D model to the actual accomplishment. Ayan. Okay. And then so this concludes, no, the webinar. So we're gonna have question and answer, no. So we're gonna have Q&A now, no? So maybe we can allot 5 to 10 minutes, no, of the webinar for the question and answer, no? Okay.